And hello, everybody. It's good to see you. We're going to start here in just a couple minutes. If you're new to the channel, glad you're here. If you're a faithful follower and joiner for these quizzes, it's great to have you back once again. My name's Keith Barker. I'm just going to get a few things set up, and then we'll start our quiz. All right, welcome Dan and everyone. I see Chris is here. Great. And Al C says, I passed my CCNA this morning. My score was 950. Oh, that's so great. Congrats. Way to go. Red's in the house. Nick is here. Also, just as a confirmation, if I could get just one or two of you to chat that you can hear my audio, that'd be great. And Dan, thank you for the shout out and sticker saying good luck to everybody. Always appreciated. All right. Thanks, Chris. Thanks, Dan. One moment. I'm going to bring up a couple of computers. All right, looks good. Here's our topology for today, or one of them that we're going to be working with. This was inspired by yesterday. This quiz brought to you by yesterday. Yesterday in the office hour, we had some great questions on static routing, and I built this topology real quick yesterday morning, and I'm using a lot of it for the quiz today. So if you joined us for the office hour yesterday, you might be primed up a little bit and ready to crush the quiz. Also, not to leave anybody in the dust, I've got some really great questions that will require some thinking. All right, I'm glad you're here. I had a lot of fun putting this together. We are going to begin. This is the pin number here. It should be at the very bottom of the screen as well. So if you see somebody coming a little bit late and they want to join, please don't hesitate to let them know that they can join by going to that URL or using the app and using that pin. I will, in the background, be encouraging people not to supply answers in the chat, but to do it in the app. And I think I have like about eight questions today, and some of them they're thinkers. So here we go. I'm so glad you're here. Spend a few minutes this weekend with me. Static routing, August 2021. Here we go. 3, 2, 1. And we begin. Question number 1 is multiple select. Which of the following is or are host routes? So I want to tell you there could be 1 or 2 or 3 possible answers. Choose the correct amount of answers and then go for it. All right. Wow, look at that. So let's talk about here's what we're going to do. I'm going to just spend a few moments on the questions where we're kind of across the board. Now, it was a little tricky because I said pick all the correct answers. And so maybe you felt you needed to pick more than what was actually needed. But let's talk about routes. Routes are like instructions in a router's brain. Think of a router like you. And if you're going to sit for an exam, think of the router like you. When we sit for an exam, we're by ourselves, really. Now, in this environment, we're here together. It's great to see you. But for the exam, we're all by ourselves, all by myself. Don't want to take this exam, but we have to. We're all by ourselves. I think of that same attitude with a router. When it receives a packet that comes in, it's at that moment, it has to make the decision on its own with all the information it has about how to forward that packet. And so as far as the routes go, the routes are the instructions in its brain, if you will. That's part of the control plane to identify how do I forward a packet? Do I send it out path A? Do I send it out path B? Do I send it out this way? C? What do I do? And that's all based on the active routing table. So when we take a look at routes, let's imagine a street. And let's call this street, we'll call the street Elm Street. Now in an IP world, we'd call the street like 10.1.0.0 with a 24-bit mask. It's all the same, just a logical representation of that street. And then we have houses on that street. And so let's say this is 123 Elm Street, this is 124 Elm Street, and 125 Elm Street, and 126 Elm Street. And you'll notice all these houses have something in common. They are all on the same street. Or if these are host computers, these could be IP addresses like 10.1.0.124, 123, etc. And they're all on the same street, even though their host or house addresses are different. So from this router, if we get a packet that was trying to go to 10.1.0. Let's pick on 124, this router is going to look at its routing table and make a forwarding decision based on what it believes to be true. That's how routers work. And if we're making so it looks at its routing table, it's going to use the longest match. And the longest possible match in IPv4 is a /32-bit route that matches. So let's imagine this PC right here. We'll call it device A. Let's say the router has a 32-bit route. Exact instructions on how to reach 10.1.0.124. And it's supposed to use this interface and this next hop to get there and forward on its way. But if that's a 32-bit route, that's an example of a host route. So if it seems anticlimactic, it is a little bit. It's just a host route. It's just a route that includes all 32 bits. So we don't have a ton of them. Like in large networks, we're not going to have like thousands and thousands of 32-bit routes, but we are going to have some, and especially including ones for our local interfaces. But that's a host route. Now, what if we didn't have a host route? Maybe the routers just had a route to 10.1.0.0/24 or /25 or /26. Well, /24 would represent the street, and that's what we would call a network route. The router's trained on how to reach the street. The router, who's 4 or 5 hops away, doesn't really care with a network route. It doesn't really care about the actual host on that street. Its job is just to forward in the direction of the street, and then hopefully somebody closer to that site will be able to deliver it. Case in point, my wife is in Northern California working on a project for a couple weeks, and I had to mail her something, and so I went to the post office, and the post office, this happened like, I guess it was Monday. The post office, I gave the address, and they said, oh, we can't deliver there. We don't do delivery to this business. It's in a rural area of Northern California. And so I said, well, can you deliver it just to the zip code and just to the post office at this one zip code? And they said, okay, we can do that. So what happened was the post office, they literally delivered it to the post office in that area. And then they relied on the local people at that area to go ahead and make sure it got in the right hands, which eventually it did. It got delivered. And that's just like how a router making a forwarding decision to a network. And then the routers who are directly connected to that network, they would do the ARPs and they would figure out how to reach the individual hosts. So a host route is simply a 32-bit route in IPv4, and a network route is simply something less, like 31 bits or 30 bits or 29 bits, etc. All right, so in this example here, the route with the highest AP, or AD rather, that's right here. And it's IP route, it's a static route, 10.4.4.50 with a 32-bit mask. And if you look at all the routes here, just look at all of them, it's the only one that has 32 bits. And it happens to have an AD here, an artificially high AD, because I pressed enter, and this got part of the running config. Normally a static route that points to a next hop address as the next hop would have a default administrative distance of 1. But this is a artificially high one. However, there's no competition for that specific 32-bit host route, so it still made it in. And that's the only host route in this table. So that was a pretty split. I wanted to create this question to reinforce many concepts and also to point out the difference between a host and a network route. And there we have it. All right, moving on. That was question 1. These are in a randomized order. And part of that's for me because every time a question comes up, because it's not the same order I created it, I have to then take another close look at it. So here we go. Question number 2 is this. Which method on router number 1 would win if we implemented a new route for 10.67.83.0/24? That would make it a network route. You have 4 choices. I'm looking for one correct answer. The best answer. All right, which method on our one would win for a new route to 10.67.A3.0? Let's take a look real quick. Yeah, this graphic has nothing to do with the question. So I threw this up there as, hey, I'm going to show them something during this question. But if we were on any router and we were learning about a new route to this is a specific route. That's a network route for that specific network. If we learned it via EIGRP, that would have an administrative distance of 90. And IBGP would be 200. OSPF would be 110 by default for internal OSPF. Well, external too. And then a static route would have a default of 1. However, if we did 115, that would make it 2 higher. So basically, there's a really important concept that I'm going to be totally frank here. I got my first CCNA back in like 1998, and then I got my first CCIE in 2001. But I continue to learn and continue to study. It didn't really sink in for many, many, many months about, the whole routing process. I want to share with you something that'll serve you very, very well, and that is this. Let me bring up this video, and I'm going to pause it and just bring in the graphic for it. This video, which is called Routes That Must Win Twice, is absolutely critical for you. And it basically explains the concept that a route has to, first of all, get into the routing table. Let's imagine it's like an election for a city government. So this is our city. It looks like a square, but that's our city. And we're going to have a mayor or some other leader of that city. And let's say we have 10 people that would like to do it. Well, unless those 10 people throw their hats in, meaning they volunteer or they run for the election, we're not going to elect somebody who didn't run for office. So let's imagine out of those 10 people that 5 of them actually ran for office. Oh, my Amazon Echo thinks I'm talking to her. Alexa, stop. I have no idea. So basically, you have to get your hat in the ring. And then after those, so let's imagine these 5 people all run for the actual office. So you have 10 people that considered it, 5 people that did. Think of that like routes that are trying to get into the routing table. So just because you're in the routing table doesn't mean you're going to be used, but it means you have a better chance of being used. So these 5 routes with the best ADs got into the routing table. That's the first element where they have to win to get into the routing table. And then once they're in the routing table and a packet comes into the router's going to say, whoa, I've got a packet going to 1067.83.90, for example. It looks at its routing table and looks for all the matches. Because you could have multiple matches, like right here. Oh, this is a bad example. But I've got like a default route would match, right? A default route matches everything. But you might have a more specific route. So we're looking for the longest match from the routing table. So if let's say I had 5 routes that got in there, and let's say all 5 match this. They all got in the routing table. I then have to go ahead and pick which one I would want to use. And it's going to be the longest match. When I say longest, you take all the routes that match, and you pick the ones that have the longest mask, and that's the one it's going to use. So this video, I wish somebody had made that for me almost 20 years ago. It would have been great. YouTube wasn't too big back then, so maybe not. But this is a very important video that will help you in understanding that routes have to get into the routing table with AD primarily as their decision point. And then once in the routing table, it's always, always, always the longest match until you come see me in CCNP, and then we'll talk about policy-based routing and some other stuff as well. But from the routing perspective, it's the longest match. All right, so this is a question about winning and getting into the routing table, and EIGRP has an AD of 90. All right, let's see how we're doing. Fast Lion, 1,656 points. All right, we have 6 questions to go. Here's question number 3. It is double points, no pressure. The faster you answer correctly, the more points you get. Which route will R1, which we're looking at here, use for a packet that is going to 10.4.4.50? Good luck, everybody. All right, which route will R1 use for a packet going to 10.4.4.50? So the correct answer is red, the static host route, but we have a lot of people on blue. Let's take a look at that real quick and see if we can come to a determination. Also, for these quizzes, our focus is primarily assessing understanding and giving a little explanation. And it's a good opportunity to identify where we need to go back and study and revisit and lab up more. So, which route will R1 use for a packet going to 10.4.4.50? And let's think through this together. So this is R1. I'm a visual learner, so I think in pictures. I do. So I'm going to draw this out as I talk about this. It gets a packet that shows up at its door, destined for 10.4.4.50. And this is its routing table here. Plus, we just added a static route as well. And let's talk about, does this static route, does it go into the routing table? And the answer is, well, it's got a super high AD. I mean, higher than default, 123. However, tell me if you see here in the existing routing table before the static route, do you see a 32-bit route for 10.4.4.50? I don't see one. And because it's not competing with anything, it goes right in. It's only an issue if we have the same exact route from multiple sources where a route may or may not make it into the routing table. So it's in the routing table. And as a result of it being in the routing table, now the packet's here. The router looks, what have I been working on? The router looks at its routing table, looks for the longest match. And I just want to point out the routes that do match. For 10.4.4.50, this route matches. That's a network route for 10.4.4. That would work. And this is also a host route that would also work. And so which one has the longer mask? This one's /32. And that's why red is the correct answer. This static host route, it first of all got into the routing table, and it's longer for that specific packet. In fact, you know what we got to do is, let me just make a note of that address, 10.4.4.50. Yep, let's do this. Let's go ahead and let me show you how a person could verify that. And this is one of the techniques that I often use is I see something, I study it, I lab it up, and then I verify are the results the same as what I'm hearing or expecting. So let me bring over a little topology here. This is, let me see if I can show you the graphic here. So this is this topology. In fact, let me just put that there on the left and put this here on the right. That way we can see it as it happens. Okay, so let's first of all just verify the routing table here on R4. This is R4 right here. And we'll do a show IP route. And this has routes to the 10. Oh, were we on R1? Let me make sure. Oh, R1. I need to go to a different router. That's okay. Let me go to a different router. That would make it look like the example, which is good. So let me bring this up again. We want to go to R1. Burp. Easy to do. Show IP route. Oh, that's show IP route. I'm waiting for the voice recognition to kick in. Okay, so here's the routes. And that's, I think, very similar to what we looked at in the quiz. And here's a really fun tip. If you want to ask the router, hey, which route are you going to use? On live gear, you can do a show IP route. This may also work in Packet Tracer. I haven't verified it. But show IP route, and then you can put in the exact route the target. Let's say we wanted to say, hey, Mr. R1, if you wanted to get to 10.4.4.50, how would you get there? We could do a show IP route and then put in the IP address 10.4.4.50. And it'll just tell us, hey, of all these routes, here's the one I'm going to use. And here it is. It says, I'm going to use the OSPF learned route and that the 24-bit route, and that's this guy right here. So it just tells us. So if we created a new, longer, more specific static route, which we can do really quickly with the IP route, and then we'll put in the target 10.4.4.50, and we'll put in a 32-bit mask. And also, if you haven't yet studied subnetting, there's not a really easy way around it. It's important to do, and that's why I created Subnet Saturdays for you. Subnet Saturdays is a separate playlist on YouTube that will, in measurable terms, walk you through the entire process so you can always get subnetting correct if you need to. And in CCNA, for real networking, it's important. All right, so IP route. Then we'll go ahead and put in the next hop. So 10.4.4 right now, my next hop is 10.1.2.2. I could also discover that with CDP, but we'll put in 10.1.2.2, and then I'll put an artificially high administrative distance. In fact, let me just not do the administrative distance, press enter, and let's see what happened there. So if we do this command again, I'm in configuration mode, so I'm going to do a do in front of it and just use the same command. Previously, it was using OSPF, and now it says, I'm going to use the static route and check out the distance, the default administrative distance for a static route. If you point to the next hop for the IP address, like we just did right here, the default AD is 1, and it's now using that route. So so if you're at the CLI, you can tell by asking it. But now we do a show IP route and press enter. Here we have our routes, and this static route is the one that we would go ahead and use. And the show IP route with that target is representing that as well. Okay, all right. I'm pleased to say that was a very useful example that gave me the opportunity to explain why the host route, because it was the longest match, was being used. Am I having fun? Are you having fun? Are we having fun? Hey, if you're having fun, do me a favor and just say loving it or enjoying it or it's useful. That'd be a lot of fun for me to go through those comments in the next screen while you're taking the next quiz question. All right, so if you want to comment, that'd be great. Oh, Bold Gator. Ooh, first place, almost 3,000 points. And, ooh, look at this, up 39 places. Zanny Sphinx, which is just fun to say, is the highest climber. Nice work. I'm so glad we're all here. Here's question number 4. Multiple select. Which new static routes could change the way R4 forwards to 10.1.1.50? We're taking our existing routing table and saying, what if we added these new routes? Could they alter the behavior for routing to that network? All right, nicely done. Before we confirm this, there was a comment, which, by the way, thanks for all the fantastic feedback. One of those pieces of feedback was, hey, you didn't try it with this route that we just did. We didn't try it with the AD of like 123 or 125. So let's do that. Let's go ahead and config T, hit the up arrow key a few times. I'm going to remove that route, take it off. No, IP route. And let's do a do debug of IP routing. And that's just going to show us changes to the routing table. Let's also do a do show IP route real quick, just to make sure we're starting off at a fresh point. And now, so there's no static route, that 32-bit host route isn't there. So now if we add the route again, and we say 123 or 125 or whatever number we want to, boom, here comes the debug. Boom, it's in. Because there's no competition for that route. So we could even use an AD of like 250, and it would still be in the routing table because there's no competition for that. So if we do a do show IP route, I've got it somewhere here. There we go. It's still using the static route, and there it is. And there's the distance of 250 associated with it. So thanks for that, keeping me honest there. And let's go back to this question, which says, which new static routes could change the way R4 forwards to 10.1.1.50? A lot of great answers here. Let's talk about why those are true. And, okay. So I like to start off with what is. This is what is right here. And currently, if we're forwarding 10.1.150, so this is our 4, a packet comes in, and it's destined to that IP address, and the router looks at its routing table and says, how do I forward? And it would say, the only match I have right now is 10.1.1.0, 24-bit network route. There's no default route. And I will forward it with my next hop of 10.3.4.3, and life is good. So if we added a /24 static route, because the static route for that same exact network has a better AD, an AD of 1, it would win. And it would push out the existing route. So that new static route could alter the behavior if we pointed to a next hop, a different next hop, and so forth. If we did a /23, it would also have an AD of 1. However, it wouldn't be the longest match. So if we did 10.1.1.0 with the /23 as a static route, the router would have both those routes in the routing table, but it would choose the longest match, so that wouldn't alter it. The default route is the worst. Think of the default route as Obi-Wan Kenobi from Star Wars. If you're not familiar with one of the quotes, it's "Help," and it's Princess Leia, "Help us, Obi-Wan, you're our only hope," or something close to that. Where if I don't have a more specific route, I'm going to the route that is the least possible specific, and that is the default route. It's a last-ditch effort that will only be used if there's not a more specific route. But we have a more specific route. It's a 24-bit route based on this. And as a result, the default route wouldn't change behavior. And then a /25, even though it has a higher AD, that's a new route. It's a longer match. And so just as we demonstrated in the previous video, or in the previous demo, it doesn't matter. If you have a unique route, what they say, I think sailors, people on the ocean say, any port in a storm, any route I have in my routing table, even if it has a terrible administrative distance, hey, it won. It was good enough. You know what you call a doctor who came in last place in his, last in his school? Doctor, right? Because he's a doctor. So it doesn't matter if they got A's or B's. The worst possible route, even if it makes it in the routing table and it's there, if it's the longest match, it's going to go ahead and be used. So I say worst because of the AD, but it's the best or longest match. All right, I'm still having fun. Again, thanks for all your feedback. That was great to read during the last question. And if you use a calendar, I know some people are in luxury where they don't have to, but I use a calendar. And if you want a calendar every weekend, Sundays, Pacific time, 11 a.m. for a quiz, this is where it happens right here. So join us, bring your friends. And there's a lot of people here today who have gotten their CCNAs and they've got their CCNPs. They just want to refresh and keep their skills, current. And I appreciate it. A lot of moderators were here today. I appreciate everybody who serves their fellow humans and having a lot of fun. There's a lot. Also today, I wrote this quiz this morning and then I did a test run of it. And I went through one of the questions. I thought, oh, that's not right. So if a double CCIE, and if you've been with me in office hours, you know that I just got to think through stuff. And I want to let you know that we're human, all of us. And it's a learning process, and we can just keep getting better and revisit, and we can learn and grow together, and we can help each other. That's my goal. All right. Rockstar Rhino, 4,200 points. Nice, nice, nice. Here's question 5 of 8. Which method on router 3 would win for a brand new route to 10.67.83.0 with a 24-bit mask? Just as a heads up, the topology is just eye candy. By the way, this question is different than the previous question we had. It looks similar to this. It's not the same question. So hopefully you didn't jump on the answer from last time because it's not the same question. All right. And Miguel, thank you for that feedback in the comments. I appreciate everybody having my back. We can have each other's backs. The only time we can't really help each other is when we sit for the live exam. Cisco is going to want to know, how much do you understand on your own, like a router making a routing decision. All right. And my goal is, from an AD perspective, I want to make sure the information gets in so you have it in your routing table, in your mind, and then you can pull off the correct answers based on what they ask. Okay, so which method would R3 use? Or which method on R3 would win for a new route to blah, blah, blah. And just as a quick review here, the default AD is 1. That's pretty good for that route. External BGP is 20 for the AD. OSPF is 110. EIGRP is 90 for internal EIGRP route. So based on just the raw data, the static route with the default AD would win. Oh, you know what? Yesterday, Eric had a great several questions he wanted to go over in office hour. And one of those was, we had like 5 routes. 1, 2, 3, 4, 5. They were like a couple of them, like, this is route A, route B, and C. So we had some that were duplicates. So we had to decide which ones go into the routing table. And then based on that, based on the packet being routed, which one would win. So getting into the routing table is based on AD, and based on the winning being routed and forwarded based on that route is based on the longest match, LM, longest match. So, hey, we were looking at a practice quiz question, and we came up with 3 correct answers based on just this output. And the quiz engine said there's only 2 correct answers. And then last night, because my brain was thinking about it, I thought, oh, one of the routes was like a 32-bit route. So assuming that the routes weren't already in the routing table, those 3 new routes would be used. They would make it in. However, if we're on a router like this, let's call this R6, and it's got an interface of 10.1. Let's call it 10.6.0.6 with a 24-bit mask. This router is also going to have a C route directly connected. It's also going to have an L route on current iOS, which is a 32-bit route for that exact IP address. So if on R6 we added a new route, so a directly connected interface has an AD of 0. So just be aware of that. It's not really obvious. In fact, yeah, let me show you. This wasn't explained to me. This wasn't explained to me when I was learning Cisco a couple decades ago, but it's absolutely the case. Let me show you what I mean. Here's R1. And if we do a show IP route, you notice these L routes that ever since like iOS, I don't know, 12-ish, 15 for sure, they started adding these dynamically for every interface. So this router is directly connected to the 10.1.2 network because of its IP address mask, and it also creates this L route, a local route. So if we did a show, what am I doing here? Show IP route. Let's do a show IP route for 10.1.2.1. That's the 32-bit route right there. Look at this. Distance of 0. So if we were, just for like fun and giggles, just to I modified that. If we were to come in and create a static route that says to reach 10.1.2.1 with a 32-bit mask, which would be 255, etc., and then we specified an X top, the new AD would be 1. And so if we added a host route for this specific network, which is a directly connected network, that 1 for the AD by default wouldn't win because the directly connected network, the local route, has a distance of 0. So that's not critical for your CCNA, but that will serve you just as a confirmation of the rules don't change. Routes get into the routing table based on if there's a conflict between 2 or more networks or routes based on the best AD. And then once they get in the routing table, all those routes are then used based on the longest match, depending on the packets that come into the router and what's the longest match to reach them. All right, I feel pretty good about that. I'm glad that command worked. There's a lot of commands out there, and we don't have to memorize all of them, and that's why they invented context-sensitive help. All right, so the static with the default AD would win there, and let's see who's in top place as we look at question 5 of 8. Rockstar Rhino! Nice. Excited Sloth, my namesake, Tropical Ferret, Arctic Tiger, and Aquatic Orcs. Also, right after this live quiz, we'll go ahead and hang out in the CCNA voice room. If you want to review or just chat about any clarification on any of these quiz questions, feel free. Also, if you're into calendaring, set your calendar to join me every Saturday, Pacific time, 10 a.m. on Discord for my office hour. It's free. It's open. So if you want to chat with me and ask me like anything about your studies that you're studying, you want clarification on something, that's the place to do it. I'm happy to help. All right, here we go. Question 6 of 8, double points. After adding this static route and using this routing table, what is the result? And Delboy571, I think you stated careful as eBGP is different from external. Oh, sorry. Delboy571. Spot on. I misread your comment. Thank you very much. Appreciate everybody. All right, that's a good majority vote. 29 out of the rest of us said current routes to 10.23.00.24 will be replaced. Now, there is a common theme through this entire set of quiz questions, and I would say one of the common themes is that routes have to win twice. They have to get in the routing table, and then once they're in the routing table, then the longest match is used. So currently, we've got for 10.23.0, which is a 24-bit route, a network route, which is right here. Let's talk about these details. Now, I cut off the codes over here, but based on the AD, this is very likely OSPF learned both of those. And we're learning it from two different paths. So we have equal cost paths. So that's the AD of 110. There's the cost, OSPF cost of 65. Currently in the routing table, they can be used. Great. However, if we add this static route, the default AD is going to be 1 because the next top is an IP address right there. That's the next top neighbor we're forwarding it to. So because the next top is reachable and it's specifying as an IP address, not an interface, the AD is 1, and these guys get pushed out of the routing table. And because they have a worse AD. So they didn't get in the routing table. See, if you're not in the routing table, if you're not running for the mayor's position, you cannot be elected. It can't be used. So this new static route would push out these two not as good routes from an AD perspective. We would now have a single route for the 10.23 network in the routing table, and its AD would be 66, which is, why it pushed the others out, and we're good to go. So the default AD is 1, and this administratively modified AD of 66 still beats OSPF. All right, I think we're almost done here. We got just 2 more questions. Rockstar Rhino refuses to let go, followed by Tropical Ferret, Agent Lark, Bold Gator, and Fast Lion. Also, when you join the quiz, when you click on spin for the name, you can spin till you get a name that you really like. And so have fun with that next quiz. And here is question number 7. Which route will R4 use when forwarding a packet to 10.1.1.70? All right, ViceNet says, "Oh, this one's easy." I don't think this one's too easy. I gave all my other questions were 90 seconds. This one's 2 minutes. So if you haven't already answered, double check your work here. Yeah, David, it happens to the best of us. Wow, I am super pleased. That is great. Now, before we chat about this answer, first of all, great job by most. And if you're just here working, learning, that's great too. If you haven't yet done so, take a moment right now, take a screenshot, make a moment. This is a playlist I have on YouTube. It's called Subnet Saturday, and it's all about subnetting because this is really a subnetting question. We'll talk about why here in just a moment. And it's just 11, I think it's 11 videos long, and it'll walk you through the pieces and parts. And so when I learned subnetting back in the 80s, and it was tough. It's like, binary, Boolean, blah, blah, blah. And I just had a tough time. I thought, no way can it be this tough. So after I struggled with it for a few years, got my CCNA. I figured it out before my CCA, of course. But my first several months were tough with subnetting. And so I basically created this series. It's free. It's just schedule yourself. You don't have to do this on Saturdays, but it's 11 videos. It'll walk you through specifically how it works from the basics all the way up through, if we scroll down here far enough, through like summarization and so forth. All right, so back to this question. Which route will R4 use when forwarding to 10.1.1.70? And again, for those of you who nailed it, my hat is off. That is fantastic. So I've been preaching longest match, right? So you think, 26. And that's where I got, 26 people on that answer. However, that route to 10.1.1.0/26 doesn't match that IP address. And so without trying to reteach all of Subnet Saturdays, if we have a /24 for 10.1.0 and a /25 for 10.1.0, or 10.1.1.0, excuse me, and a /26, the range here for the host addresses is 1 through 254-ish, and the range for this guy is going to be 1 through, let's see here, 25. What is it going to be? That's the block. 128. 128 or 126. Can't use the broadcast. And then for /26, the block size is 64, so it's going to be like 1 through 62. I think that's right. So, and if you look at which ones match, the host is .70, so that matches on the /25. It doesn't match. .70 doesn't fall in the range here for a /26, so we have to take that one off the list. It's not the longest match. It's got a 26-bit mask, but it doesn't match the actual destination. So here, the correct answer is what wow, look at that. I got to tell you, this one takes a little bit of thinking. This is a subnetting question, and regarding, which route a router will choose. So I'm super proud of all of you who nailed that. And for those of you who I have no clue, you need to check out Subnet Saturdays first, and then make sure you have subnetting down. And all these concepts are going to compound and work together towards your benefit. So it's a win-win. OSPF and routing and static routes and dynamic routing and how layer 2, all the components are going to help you build a full picture of how traffic goes from this part of the network. Let's go ahead and grab a picture here. Like from a PC over to a server or to another PC or out to the internet, including NAT and translations. And so it's a journey. It's a fun journey because once you have the fundamentals in place, those will serve you how long? Forever. IP is not going away. I mean, we have creative overlays these days of working with it, but the fundamentals of IP and IPv6, IPv4 and IPv6, they're not going away. All right, let's. I think we have one more question. And Rockstar Rhino still on top. Here's the last question. What is the best option for completing the forwarding static route below? Now, let me just clarify. When I talk about forwarding static route, I'm talking about a static route that actually forwards packets and not dumps it to a trash can. Great job. Great job. This is a fun one too. Let's go ahead and just take a peek at it. What is the best option for completing the forwarding static route below? And I'm going to draw out, what is this? This is router 3. Great. It's got some interfaces. Fantastic. It's got a couple of directly connected routes. That's the C. And it has a couple, 3 EIGRP learned routes, which have an AD of 90 right there. Great, great, great. All in the routing table. And then we're adding a static route. And how do we complete this? Well, what we should not do, because this is Ethernet. So let's say this is, these are all Ethernet networks, not serial point-to-point, nothing like that. Just like traditional Ethernet high-speed networking. We don't want to use an egress interface just all by itself like this, like gig 0/6. Because if we do, here's what happens. Let's say we did this. We said 0/6. Let's say I'm picking an interface here. 10.1.1. Let's go ahead and pick gig 0/6. Yeah, gig 0/6. If we were to do that and press enter, this route would now be used instead of the EIGRP learned route because this static route has an AD of 1. And so, well, if it's directly connected, this static route is going to have a lower AD. Let's just say that. There's some differences if you use a static route with the next hop address versus an interface between 0 and 1. So that's okay. But it's going to have a lower AD, so this route will be used. But if a packet now comes into 10.1.1. Let's say 45, and it shows up at the router, it looks at the routing table and says, oh, the egress interface is 0/6. I'm going to go ahead and ARP for it. Now, this network here, 0/6, is the 10.2.3 network. So what's happening here is this router is going to be ARPing on this interface for 10.1.1.45, saying, hey, I'm trying to resolve this layer 2 address that's associated with this layer 3 address. Now, it's the wrong network. However, routers by default, most of them, well, I should say most, Cisco iOS routers running 15.x code, they will have proxy ARP enabled by default. So if they hear somebody saying, hey, what's the IP address for 10.1.1.45, they'll go ahead and respond, and if they have a route to that network, or if they have any route, including a default route, if they have a route to get to that destination, they'll respond with their own layer 2 address. So the ARP cache will be populated on R3. But what if you have like people going to the internet and there's like thousands of destination IP addresses that we're trying to reach? R3 is going to ARP for all of them. And then poor R4, or whoever the next device is going to have to do proxy ARP vias and respond. It's not the right thing to do on Ethernet. It's the wrong thing to do on Ethernet, is just to specify the interface all by itself, because it'll cause ARPing on that local interface for every destination IP address. Everyone that's not on that local subnet. So the solution to that would be, if we're going to use an interface, you'd also want to include the IP address. And the IP address here would be 10.2.3.2. That's the next hop router that's already reachable. And what else? And you don't even have to add the interface. Now, the reason the interface is there too, you might want to do the IP address and the interfaces. Maybe you had multiple physical interfaces that could reach that destination off. So you could, if you wanted to pick one, you could do the next hop IP address and the interface. But for CCNA, if you're on Ethernet, which we are today, don't put the interface, the actual physical interface. I mean, you can, but the right answer would be the next hop address, and then if you want to include the interface as well, but don't put the interface all by itself on Ethernet because it'll cause the ARP. Now, what's wrong with this answer right here? If we told this router that the next hop was 10.5.2.2, it's not directly connected to the 10.5.2 network. It's not, who do I hand that to? So if the router has a route to 10.5.2.2, meaning it can forward in that direction, it will go ahead and allow that route to happen. It does a recursive lookup, which is also a little bit beyond CCNA, but ideally you'd want to have an IP address for a next hop router that's on the same next subnet that you're connected to. However, if you point to 10.5.2.2, as I did here, and there's no route for that route is not going to be added to the routing table because the router says, whoa, to get to, for example, 10.1.1.0, the next hop is 10.5.2.2. I don't know how to get to 10.5.2.2. So as a result, my next hop isn't reachable, and I'll just go ahead and not put that in the routing table. Because if the router doesn't believe it can reach the next hop, either through a lookup or directly connected to that network, it's not going to bother adding it to the routing table. All right, so what do you need to pull away from this? Always use the next hop address on Ethernet. And if you're not sure what that next hop address is, this is R3. There's some ways of figuring it out. Now here it's showing us the next hop for that, but we could also just go to the router. And on a live gear, you could use something like this. So let's go to R3 and do a show CDP neighbors. And if we knew it was R2, we could ask R2. We could discover that with CDP to show CDP entry. R2, you put the name in, case sensitive, and that shows us, oh, there's the IP address right there. So that's his management IP address, but also it's the IP address used on that interface. And when we're working with cloud services, and like most of the time, as you work in IT and work in networking, the gear is not going to be right next to you. You're not going to be able to physically walk over and see it. So you have to use tools like CDP and link layer discovery protocol and show commands to help verify, like ARP tables, to help verify where the heck stuff is. And so all this is useful. It's all building and going to help you round out your support. But the key here is the best option for completing a static route on Ethernet would be to put the next hop IP address as that next hop. And if you want to do a floating static route, you can artificially increase the AD at the very end of it to something higher than the existing route in the routing table. All right. I appreciate everybody. Let's take a look at the winner's podium, and then right after, we'll go ahead and I'll give you some further instructions if you want to join me on Discord right after. And here's the winner's table. You're all winners, but here's the top 5. All right, Rockstar Rhino, Tropical Ferret, Bold Gator, nice work. And let's go ahead and take a look at this. So out of 8 questions, we had 5 that were most difficult. And the one was, question 5, which of the following is or are host routes? There was only one host route, but I showed it as a possible multiple choice. So that tricked a few people. In the live exam, they're not going to play that kind of game. They're just going to say, choose all that apply, or choose 2 or choose 3. They'll give you check boxes. And for the ones where I have a single answer, they'll say choose the right answer. It'll have a radio button. You click on it. It's not going to be, I wonder if there's 5 answers. Oh, I've had exams like that. They're terrible. Where it's like, there's like 6 options. Choose all that apply. Oh, no. How much time do I have? All right. And then which new static route could change the way R4 forwards traffic? And then which route will R1? This is very useful for me too. And I'm going to make I have some new exciting stuff coming to the channel. I think you're going to love it. I'll let you see it when it comes out. But if you want to join me right after this quiz, we'll go ahead and we'll be in the Discord server. There's a link for that. There's an invitation to my Discord server. It's also free. If you want to join us and ask questions or do any quick follow-up on this quiz, feel free. And let me get some feedback from you as well. So take a moment on your screens, whether you're logged in or using the app, and let me know if this has been useful for you. I'm with you. Sometimes all these quiz questions I wrote specifically to drive home points and help reinforce concepts, because I thought to myself, what do I want to make sure they have in their minds as far as understanding? And then how do I write a quiz question that could drive home like 2 or 3 of those points on almost every question? So Eric asked yesterday in Discord on the office hour, he said, what's the best way to prep, 2 or 3 days before your exam? What should you do? I would strongly recommend going through my quiz playlist, which has recordings of most of my quizzes, and going through those, spot checking your understanding, and not looking for memorizing answers, because that won't help, but look at the question in the recordings of the playlist and just say, okay, what is the answer to this? What do I think the answer is? Why do I think the answer is that? Then look at the answer. And if you're wrong, that's just an opportunity to go ahead and improve. So again, thanks for your feedback. I appreciate that. And I wish you the best in all of your studies. I will see you. Let me give you some exit music here. I will see you in Discord if you can join us, or if you want to join us for the office hour next week on Saturday. I guess that'd be later this week, Saturday, 10 a.m., or for the next quiz, which would be 11 o'clock a.m. Pacific time here on YouTube. So I'll give you some exit music with my appreciation, and I hope to see you all soon, and I wish you all the best of success. And remember, be kind to everybody. Catch you later.